Tell me, what is an heap? Heap data structure. What is it? What is a heap? Can anyone let me know? So heap is what? A complete binary tree. Okay. What do you mean by a complete binary tree? Tell me that. What have we discussed as per the definition? What is a complete binary tree? Can you let me know on this? Heap is a complete binary tree. That means if I am having a binary tree, right? 1, 2, 3, 4, 5, 6, 7, right? And let this be 8. All the levels would be completely filled except the last level. Last level may or may not be completely filled in that case. That is what we call as the complete binary tree. Now, if the last level is to be filled, then from the leftmost to the rightmost position in this manner, the overall filling should be there. Then only I can say that the given binary tree is a complete binary tree. Okay. Any doubts corresponding to this? What is a complete binary tree? Tell me that. All the levels except the last level would be completely filled. Last level may or may not be completely filled. Okay. And if you are filling the last level right from the leftmost to the rightmost position, in this manner, the filling should be done. That's when I can say that the given binary tree is a complete binary tree. Now, heap is a kind of complete binary tree, right? Heap is a complete binary tree. Now, what kind of heap I may have? What kind of heap I may have? So there are two kinds of heap that we will be dealing with. One is min heap, another one is max heap. Okay. Can anyone give me the definition? What do you mean by min heap? What do you mean by max heap? Tell me. What is min heap? What is max heap? What is min heap? What is max heap? Tell me that. Anyone? Min and max heap. What's the definition? Okay. Again, this is a binary tree, right? Heap is what? A binary tree for sure, right? So if I say, see here, 1, 2, 3, 4, and let this be 3 and 5. Correct. This is a min heap. If I say this, am I correct? What do you mean by min heap, right? Corresponding to any subtree. Okay, corresponding to any subtree's root will contain the minimum value. Okay. If overall tree is a heap, right? Any of the subtree will also be a heap. If overall tree is a heap, any of the subtree that has to follow the rules of heap only. It cannot defy that. Now, if the overall heap is a min heap, each and every subtree will be their respective min heaps. What is a min heap, by the way? Any of the subtree's root will be having the minimum value. All fine? Any of the subtree's root will be having the minimum value. Fine, is it? So, is it following the rules of a min heap? Tell me that. The overall root of the tree is the minimum among all the nodes, right? Come to this particular subtree. That is starting off from the left child of 1, that is 2. So whatever subtrees values we are having, right, the root value 2 is the minimum. Come to the subtree of 4, single node, whatever it is, that's going to be counted as the minimum one. Subtrees of 3 and 5 individually, they are min heaps. No problems at all. So overall tree is a min heap for me. Overall tree is a min heap for me. No problem onto that. Am I correct? Am I correct? Hello.
Yes.
Fine. Okay, now if I say then, contrary to min heap, if I ask you the definition of max heap, what that should be? What that should be? Tell me. Contrary to the definition of min heap, if I ask you what's the definition of max heap, how would you define that? That's a heap only, complete binary tree, right? So root of the entire heap should be the maximum value. Am I correct? Root should be having the maximum value. Now, any of the subtrees where I am going, right? Any of the subtrees, wherever you may step on. Let the subtree of 4 be there. Let the subtree of 1 be there. Right here, whatever subtree starts up from 4, root value has the maximum. This subtree has a single value, root, whatever it is, that would be counted as the maximum. Now again, a few subtrees that starts up from 3 and 2, they are respectively single nodes. They are maximum in nature only. That's how I can count. So overall tree is going to be counted as max. All fine. Both the definitions are clear. What are heaps for us? Let me know on this. Are the definitions clear? What is heap, what is min heap, and what is max heap? First tell me that. Is it clear for everyone? Please tell me, at least respond whatever you wish. Yes, no, whatever you are feeling. Else how would I understand?
Clear.
Okay. Okay then. So fine. And how would you represent heaps? Let me take the example of min heap, by the way. 1 is here, 2 is here, 4 is here, then afterwards 3 and 5 is there, right? How would I represent this? This is the min heap, right? Complete binary tree. All the levels except the last level is completely filled. Correct? How would I represent that? See, so I can represent them with not so fancy convention, but simple via the convention of an array. Works. The root of the tree, that is at index 0. Root of the tree is present at index 0. Okay. Then see for here, the child nodes of 1 and 2. Sorry, child nodes of 1, that is 2 and 4. They are residing at index 1 and index 2 respectively. Correct? 2 and 4 are the child nodes of 1. Lefter child is 2, present at index 1. Righter child of 1, that is 4, resides at index 2 for us. Fine? All fine? All fine? Now
Yes.
see for what would be happening is these two nodes remaining, index 3 and index 4. Index 3 and index 4, they would be containing the respective nodes 3 and 5. Going well? Going well? So that is your whatever node we are having at index 1, whose value is 2. I can just say that its lefter child is 3, residing at index 3. Its righter child is 5, residing at index 4. This is how, in terms of array, I can try representing the entire heap structure, right? Okay, now let me ask you a question. If at the ith node, right, the root node of a subtree is residing. If at the ith index, root node of a subtree is residing, its lefter child and righter child, at what particular indices they would be residing? Can you try formulating this? If at the ith index,
I plus 1, I plus 2.
is it always correct? Suppose that corresponding to this 4, right? Corresponding to this 4, you have 1 and 2 again. 1 and 2 again as your respective, or how should I change that? Let that be 3 and 2. Let that be 3 and 2. So I think right now in index 3 and 4 were there, now 5 and 6. At respective indices 5 and 6, right? Your these value would be residing. Your values 3 and 2 further would be residing. Okay. So is the formulation working? If at the ith index root is residing, its lefter and the righter child would reside at I plus 1 and I plus 2. Is it holding correct? Is it holding correct?
2 square plus 1.
Yeah, I think the root node was at index 2. So I can just say its lefter child is at 5. Its righter child is at 6. So if at the ith index, right, the root is residing, its lefter child resides at 2 into I plus 1. Okay. And righter child resides where? 2 cross I plus 2. Is the formula working fine? First tell me that.
Yes.
Okay. So this is how the formulation works overall. This is how the formulation works overall. Okay. All fine. Let me know on this. All fine.
Yes.
All fine so far. First, let me know, all of you. Any doubts you people are having? Now let's move on and let's say that how can I try converting? Suppose any random binary tree is given to you. 1 is given, and let there be no 1, but let there be 4. let there be 3, then let there be 2, then let there be 1, let there be 6, let there be 7. Now I wish to convert that in terms of a min heap. This is the complete binary tree for me, right? So I need to convert that to min heap, right? How the array structure would be looking like 4, 3, 2, 1, 6, 7. This is how the array structuring is looking like, right? So my point is right now, is it a min heap initially? Is it a min
No.
heap initially? So what is it by the way? It's not a min heap for sure. That's a complete binary tree and I can try converting that to min heap. Now let me know what segment of this tree is initially a min heap. Can you let me know on this? What segment of the tree is initially a min heap? Let me know.
Bottommost.
So I think all the subtrees, all the sub heaps that are starting from the leaf nodes are the respective min heaps initially. Am I correct? All of you agree with me? Whatever sub heaps that are originating from the leaf nodes, they are by default min heap in nature, because from under them there are no particular nodes that follows. So I can just say, right, from the previous level onwards, from the second last level onwards, let's start grabbing the nodes whatever I am having and their respective sub heaps. If they are not min heap in nature, I would start on converting them. Can I just say that? Whatever sub heaps you are having, suppose that the sub heap that is starting off from 3, 1 and 6, this is not a min heap initial. Though 2 and 7 is an initial min heap, but it's not any guarantee. There is no guarantee that it would be a min heap. So what I would start doing is, leaf nodes are always min heaps in nature. Even if you are converting to max heaps, since there is a single node in the lowermost level here, right? They are all min heaps in their respective nature. Now, whenever I go to the second last level, from these nodes onwards, I have to start converting these particular heaps to min heaps. Correct? I have to start converting these particular heaps 2 and 7, 3, 1, 6 into their respective min heaps. How shall I try doing it? How shall I try doing it? Let me just grab and let me say that whatever sub heaps that start off from the node 2, right, one by one, from 2, whatever nodes are part of your heap that starts off from 2 onwards, let me first convert them. Then I would be saying that whatever nodes are a part of heap that starts off from 3, let me then convert the entire thing into a min heap. And then at the end, when entire substructures are converted to respective min heaps, right, I can just say, okay, starting from the root onwards, let's take a call and try converting the overall structure to a heap. Okay, let's start converting the overall structure into a heap. So how should I try doing it? Let me know on this. What you will do? This, you are just constructing heap for the first time. It's not initially a heap, but for the first time, any random array is getting converted to a heap. Min heap specifically. So now what should I do? You are right now standing at index number 2. Am I correct? At index number 2, you are standing where the heap value is equal to that of 2. Am I correct here? Am I
Yes.
correct? Okay, now what you are going to say? I am right now at this particular structure, currently concentrating on this structure, sub heap that starts off from 2 and deciding at index 2, right? So see, corresponding to this particular node, right? Its lefter child is what? Its lefter child is greater. So this cannot replace the current root node. There is no righter child as well. That means I can take a call. This is already a min heap for me. Am I correct? This is the identification. You are particularly taking a call that, right? Right now I'm standing at root node R. There is a lefter subheap of this. There is a righter subheap of this. They are all min heaps in nature. They are all min heaps in nature. By default, they are min heaps. Now, their respective root nodes are not greater than the overall root of the min heap that I am considering right now. So if the root node is not greater than the current, so if the root node of the lefter and righter subheaps are not greater than the current root, then overall can I say that the root among entire structure is the smallest one. Will you agree with me on this? Will you agree with me on this?
Yes.
Main convention is, suppose that right now I am having a root node X wherever I'm standing, and it is having two child nodes Y and Z. Further, Y is the root of the lefter subheap, Z is the root of the righter subheaps. This is also a min heap for me initially. This is also a min heap. Unless and until I convert the sub heaps that starts up from y and z into min heaps respectively, right? I cannot convert the entire structure to a min heap. Not possible for me. Firstly, these segments have to be min heaps, then the overall structure can follow the convention of a min heap. So right now, if they are minimums, right? If this sub heap that is starting from y and the sub heap that starts up from z, if respectively they are min heaps, y and z, I feel they would be the minimum in these segments. Am I correct? This is also a min heap. This is also a min heap. If that's true, if that is true, y and z would be the minimum in these respective segments. No other nodes in these segments can be greater than them because they are respective min heaps into their zones, right? Now I say that y is also greater than x and z is also greater than x. That means overall x is the smallest in the entire segment. All of you agree with me?
Yes.
Agree with me? That means the entire segment currently is a min heap only. I don't need to make any changes. I don't need to make any changes. Okay, so let's move on to the min heap, right? Let's move on to the min heap conversion that starts off from node 3. What should happen here? Tell me that. What should happen here? Concentrate on this segment 3. I am trying to convert the segment that starts up from 3 and its left child is 1, right child is 6. These two are respective min heaps in their respective zones. I know that this is the root, right? Root should be containing the minimum node. So what should happen then? Tell me. What should happen?
There should be swap.
Okay, so I should be minimum. This is the root of its subheap. 6 is also the root of its subheap. Left child is smallest among these three nodes. All of you agree? Left child is smallest among these three nodes. So I should say swap the nodes 1 and 3. Swap the nodes 1 and 3. So the overall structure would be looking like 1. And afterwards 3 would be here and 6 will be here. Fine. If I swap 1 and 3, how the overall structure is looking like? 4 is initially here, 1 comes into the picture, 3, then 6. No need to make any changes to 3 onwards because 3 would be the leaf node for me right now. And afterwards, I feel 2 is here and 7 is here, right? That's it. That's it. Is the entire segment converted to a min heap? Let me know on this.
Yes.
This is the entire segment converted to min heap? Yes. This segment also, this segment also. Okay, then. Next, what should I do? Move on to the overall structure right now. Overall root of the tree, 4. If I am to convert the entire binary tree to a min heap, then I think the root should be having the minimum possible value. Am I correct? Overall root should be having the minimum possible value. How you are trying to convert this? How can I try converting this? This is also a min heap. This is also a min heap. Then what should I do? Okay. 4 is there, 1 is there, 2 is there. Into the lefter segment, 1 is the minimum. Into the righter segment, 2 is the minimum. All other nodes are greater than 1. All other nodes are greater than 2. So one thing can be there. Either the root would be the minimum, either 1 can be the minimum, either 2 can be the minimum. No other node can be minimum apart from these 3 nodes. All of you agree with me on this?
Yes.
If you agree with me on this, so I would say that, okay, left child is having the minimal possible value. So swap it with the root. Swap it with the root. This particular minimum value should be present in the root in order to make the entire tree to be a min heap, right? So 1 goes here, then 4 comes here, then 2 remains as it is, right? So I am able to see that the writer region, the writer subheap is not changed yet. This was already a min heap. This is still a min heap. No changes. But consider the lefter subheap right now. 4 comes here, 3 comes here, 6 comes here. Then what is required to be done? See, right now the lefter subheap, its minimum nature is distorted. Am I correct? Its minimum nature is distorted in nature. So what should I say? What should I say? Convert this back to a min heap. Am I correct onto that? Convert this
Yes.
back to a min heap. 1 is already here. Then 2 is here. Then 7 is here. Don't touch it anymore. And convert this back to a min heap. Right? So if I'm converting this back to a min heap, the lefter segment, 4 and 3, I think would be swapped with each other. 4 and 3 would be swapped with each other. Am I correct onto that?
Yes.
4 and 3 would be swapped. 3 comes here, 4 would be here, and 6 will be here. Okay. Right now, the overall structure converts to a min heap. All fine? Is it happening? Is it happening?
Yes.
Okay. So from where should I start off the Heapify operation? Let me know on this. From where should I start off the Heapify operation? Whatever I have done, this is what you call as Heapify operation. Convert any random binary tree, what is complete in nature, to heap. So this operation is what we call as Heapify. Okay. So how would you convert this? From what particular segment I should start the heapification process? Tell me that, all of you. From what particular segment I should start off with the heapification process? So I think we started off from index number 2 here, right? 0, 1, 2, 3, 4, 5. Or if these are the indices from the index number 2, whatever node is residing here, from here onwards, the heapification process would be starting off. Am I correct? Am I wrong? Tell me. Am I correct? Am I wrong? So what is how can I try locating this index from where to start off by the way? If n equal to 6 here, right? From where will you start? Can I just say it's nothing but n divided by 2 minus 1? From this particular index, I should be starting off the heapification process. If there are n nodes inside your heap, start off the heapification from n divided by 2 minus 1. This particular node works. Will it work? Tell me that.
Yes.
Okay. So how would you write the heapification process? How would you write the function? Let me know on this. What's your take on this? So I think, yeah, there be bits, standard C++ dot H. Right, let there be void heapify. Void heapify, that takes your entire array, right? That takes your entire array. Okay, correct. And from where to where I should be starting? Okay, let's first have the array and then we'll take a call how to proceed ahead. Let there be an array, or let there be a min heap that I am considering, right? And this is containing what data points for us? Tell me that. 432167, right? 432167. Am I correct? Am I wrong? This is what the array is, and let the size of the heap be having, let it have 6 nodes exactly. Okay, now I would be saying heapify the given array. Heapify the given array, but simply heapify operation will work in this case. Tell me that. I should be passing on, right, from what segment you are trying to heapify. Okay. From what segment you are trying to heapify. Am I correct? Am I wrong? Should I be doing it? From what segment? That is from what index you are actually trying to heapify the sub heap right now. It's not that straight away I can start off from the root. I have to start off the heapification process from n by 2 minus 1, right? The leftmost node that I am having, right? Into the rightmost node, basically. Sorry for that. The rightmost node of the second last level given inside the heap. So let me run a loop for that. So I would be saying for int I, that starts off from I n divided by 2 minus 1. And then what will be happening? I greater than equal to 0, I minus minus. Keep on running the heapify on the given array, right? Whatever I'm having, heap. And that starts up from the ith index. That's how I may try running it. Now, how would you heapify, by the way? Tell me that. How would you heapify? So there are two things. There is an index here, right? int idx, where I am standing, what segment, starting from what index, I am heapifying the entire process. Tell me, how should I proceed ahead now? Firstly, I may try considering, right, the minimum resides at array's index. How would I take a call that? How would I take a call basically that current heap that starts off from the given index is not a min heap? How would you take a call on that? Let me know on this.
Sir, left subtree देखो sir, right sub.
Okay, so initially I would be assuming that at the current index, the minimum value among the given subtree is residing. Then how would you proceed? So let me let me just say that the min resides at the current index. Then how should I proceed ahead? How should I proceed ahead? If suppose, yeah. How will you proceed ahead? Let me know. Tell me.
Sir, যদি স্যার লেফটে ছোট থাকে স্যার।
If 2 into index plus 1, right? Am I correct? The left at child. Arrays 2 into index plus 1. Left at child is what? Tell me. Is
Greater
smaller than array of min. Am I correct? Will it work? Then I can just say min will be equal to that of 2 into index plus 1. Works? Okay, then consider again if array of 2 into index plus 2, right? Another comparison. Is this the minimum overall? Then so far, whatever minimum I have got, right? Array of 2 into index plus 2, this would be lesser than array of min. Works? Then I can just update array of min would be equal to 2 into index plus 2 in that case. This part is done. Then what will happen next? What will happen next? Tell me that. I can just have the comparison, right? If min is not equal to that of index, definitely into the root, currently whatever value I'm having, that's not the minimum. That's why min so far is not equal to the index that has been passed on. Then what should I do in that case? What should I do? If min is not equal to that of index, swap. Will it work? Swap or not? Swap array of index with what? Swap array of index with swap array of min. Is it that? Can I just say this? Swap the values and then do what? Perform Heapify again, right? The lefters we have already seen. Am I correct? Am I correct that we have already seen that 1 was the left-hand child, 4 was at the root, and 2 was the right-hand child? Am I correct? Now, whenever 4 and 1 got swapped with each other, I think 1 and 3 was here and 6 was here maybe. Whenever both of them got swapped, 4 and 1 got swapped, right? 1 came here and 4 came here. The entire lefters sub heap, whatever I was having, its min heap nature was getting distorted. So I have to heapify this entire segment again. I have to heapify this entire segment again. So how I should be calling that? I should be calling what should I do basically? What should I call? What should I do? That given the array, whatever it is after the swap operation is being done, right? Pass on the minimum index from this particular index onwards, perform the heapification process again. That's it. Recursively call the heapify operation. And at the end, your entire heap would be heapified. Works? Works for everyone? Let me know. Works or not? Does it work or not? Let me know on this. So this is the heapification process all about. After I have heapified, let me try printing the array values. For int I that starts up from 0, I less than n, I plus plus. Just see out your heap of I, right? That's it.
আমরা সোয়াপ করার পরে ওই জিনিসটা ডিস্টর্ট যাতে না হয় তাই আবার কলটা করলাম, তাই তো? রিকারসিভ কলটা
ওটাকে আবার হিপিফাই করতে হবে, তাই তো? সেগমেন্টেশন ফল্ট, where is it by the way? Heap of I minus minus. Are we trying to access any particular value that does not exist at all? Tell me that. So okay, fine. Let's provide here, right? What is the minimum? What is the number of nodes I'm having? One thing is that, yeah, n needs to be provided. Why we got a segmentation fault? Can anyone let me know? See, for here that whatever I'm trying to access, 2 into index plus 1, that may go out of the bound, right? If it is lesser than n first, if 2 into index plus 1, if it is lesser than n, then only go ahead and check whether then only go ahead, try accessing the value and comparison. Firstly, the particular index has to reside, has to be a proper valid index. Then only the comparison of values can be done. Else you are going to get a segmentation fault. So that's a mistake that we were doing and this should be avoided. Okay, that. Let me try running it now. Let's see. Okay, I'm sorry. Min will be here and n has to be passed on. That's it. 1, 3, 2, 4, 6, 7. Was it the respective heap that we got? Tell me that. 1, 3, 2, 4, 6, 7. Yes. All fine then?
Yes.
All fine or not? Tell me. Okay, so tell me for one thing that in a single iteration of Heapify operation, how many function calls will be made at most? Inside a single heapification, right? Inside a single heapification process, you are just comparing a few values and you are making another heapify call. How many maximum calls in a single go I can have? What are your thoughts onto this? In a single go, how many heapify operations I may call on? So I think what's the definition of a complete binary tree, by the way?
The number of subtrees we have.
It's not exactly right. You are having the root, right? You are having the root. Suppose I'm having a node number 1 from here. It would go on to 2 and 3. And then I say that it would go ahead and have 4 and 5. Then again, there is a 6 and 7 involved. Then there is again what? 8, 9, 10 and so on. So suppose that there are 10 nodes. How many levels of the entire, there are 10 nodes. How many levels we are having exactly? How many levels we are having exactly? Let me know on this. So basically, I may try saying that how many nodes per level. How many levels are there? So I can just say 2 to the power 0 is the number of nodes I'm having into the first level. Then 2 to the power 1, then 2 to 2 square, then 2 to the power, some 2 to the power x, right? If this is the maximum number of nodes I have in the last level, all should be lesser than equal to n. So if this is the relation that's coming, there would be x number of levels. So x would be at max log n in this case. All of you agree with me? Simple relation this is. You just add the number of nodes per level. So the last level in the worst case will also be filled up, right? In the worst case, your last level will also be filled up. Number of nodes will also be some power of 2, some greatest power of 2. So what can be the maximum number of levels I can have? If there are overall n nodes, that would be no more than log n. So tell me for one thing that if there are no more than log n levels, then how many times heapification process will be called in a single go? Maximum number of times single heapification process can take place. Tell me.
Log n.
How is it log n? By the way, you start off from the root, right? Suppose that root is being replaced by the left child. Now I won't be touching the sub heap of the right child. Am I correct? I won't be touching it at all. It's completely eradicated. Now, since both of them got swapped, I would be saying, okay, run the heapify process again, or whatever sub heap that starts up from the left child onwards. Now, further, suppose left child's left child is there, right? They get swapped with each other. Again, run the heapification process recursively onto the sub heap of left childs. The current left child, whatever we are dealing with. Further, it is getting replaced by its left child. This process will go on till the time I reach the leaf. So at most log n calls would be there, not more than that. Okay. If recursively you keep on calling, there would be at most log n calls. Okay, recursively heapify the sub heap that got distorted. No more than log n calls would be there. Okay. So in a single heapify operation, it involves no more than log n function calls. No more than that. Okay. And for each of the log n function calls we have made, some k constant unit operation I'm performing. So single heapify operation takes no more than log n function calls, correct? No more than log n function calls. Overall, how many times we are calling for the heapify? Can anyone let me know? How many function calls overall we are making here? How many times
Number
the loop?
of levels.
How many times we are calling the loop? Let me know on this here, right? It is here. I can say roughly n by 2 times I'm calling it. Am I correct? N by 2 times I'm performing the heapify, calling the heapify with different set of nodes. And further, a single heapify operation will take log n function calls to complete at max. So it's gonna be n by 2 into log n. Correct? Enclose that into big O 2 is a constant. Overall, the complexity is gonna be n log n. Works for all of you? To construct a heap or in order to perform the heapify operation on any random binary tree, right? That's complete in nature. The overall complexity that is involved is n log n. Is there any doubt corresponding to this?
No.
Representation of heaps, converting a particular any random binary tree that is complete into a min heap. How to do it? We have seen them all. Fine.
Yes.
Any particular doubts you people are having, then let me know.
Clear.
Any particular doubts? So max heap, the max heap conversion, can you try doing it? How to convert a particular any random binary tree that's complete in nature into a max heap. Will it be doable by all of you? Let me know. Can you try doing it? And
হুম
you have to convert it into max heap. That's it. হিপটা
শিওর
বোঝা গেল বলো, হিপটা বোঝা গেল
গেছে
all of you?
এটাই তো স্যার হিপ সর্ট করলাম
No, it is to the heapification. Heap sort is different thing. You are whatever array is being given to you, you will sort the entire array with the help of heaps. Getting it? That's what we call as heap sort. That's what you call as heap sort. Yes. Inside that, we will take the advantage of heapify operation. But I want all of you to get thorough with the heapify operation first. Then we will go ahead with the heap sort. Works. So for that, you have to first implement what? You have to first implement what? Convert to
Max.
max heap conversion. Simple it is, I feel, from here onwards. Any doubts? Let me know.
Here.
Okay. You bring the max heap solution in the next class, then I'll move on to heap sort and we'll take problems on heaps. Works? This is
Yes.
the basic of heap that I've discussed. It's not very 1-2 class I would require to finish heaps. That's it. Not a very big deal. Fine then. And then we'll move on to graphs.
Yes.
Any doubts? Any doubts?
No.